everyone, welcome back. And today, on request of one person, and on very request of one person, I am starting a series of videos on differential equations. So, whenever we do some work, there is some inherent purpose behind it. Whether the purpose may vary from person to person, just like if why are you pursuing any degree like BSc, MSc, or BTech, or etc. So, if I go for the survey, the purpose may change from person to person. Some are pursuing just for knowledge, some are pursuing for good job, some are pursuing just for sake of degree, and many other reasons are possible. So, there are also purpose when we do some work, and if someone is studying a course on differential equations, there are also some purposes and why one should learn differential equations. So before going to the reason, I would like to tell you some aspects and applications which will motivate you why the differential equations are necessary in our life, and how do they not only make our life simpler but show us a different looking to the our physical world or our universe. Just as you might have heard about and learned about Newton's second law of motion, what actually it is? It is a second order linear differential equation, that is, force force is equal to mass times acceleration. If it is a point par- force is mass times acceleration. If it is a point particle and it have the mass m, and we apply a force that is vector f, then its acceleration will be vector a. And we know that acceleration a is nothing but second derivative of position vector, that is this quantity. So this is vector f is equal to m times d2r by dt2. This is vector. If we remove this vector quantity, I can write it f is equal to m times d2r by dt2, and this vector f may be function of position r and time t. So we can write this is r and t. And this equation, which you might have learned in your since your ninth standard to 12th standard, you might have seen its beauty of this differential equation. You don't know at that level, and at that time we don't understand about the this differential equation, but we learned it by heart that this is the equation of motion and this is for displacement. That is, we learned that velocity v is equal to u plus at, where v is velocity at a time and u is the initial velocity and a is acceleration and t is time. And we also learn one equation, that is s is ut plus half at square, and v square is equal to u square plus 2as, where s is displacement and t is time, a is acceleration. So this you might have seen, and you have already seen the beauty of this equation, and you have seen wide application of this equation. And when we throw some ball, and uh, in many cases we have used this differential equation, but just by using these three laws. So we will study this in detail, and we can easily derive these three equations from this equation. And you might have seen in just last period, that is COVID period, you heard that IIT Kanpur means a team of IIT Kanpur predicts that the third wave or the second wave of the corona will be in this time period. How do they predict? They also do the physical modeling of that situation and put some restrictions, and the initial they find some data from last disease and last period, and putting those values they solve the differential equations. In all cases it is not possible to closely solve a differential equations. In that case we have the numerical solutions, and you would learn it further, that is known as numerical analysis. By using those rules one can solve any hard to hard, whatever is the hardness of differential equation, we can approximately solve that. So in that case also the differential equations are solved, and then we predict that at that time period this will be the uh, time when the peak of the corona will take place. And you might have seen that our space agency or weather, they they tell about the weather that in that day or in that date this will be the situation, there are these many chances of rain and about uh, they tell about many things. In weather forecasting we also use the differential equations, and also in economics, that our stock market will take this rate, and this will be, and many other things. In economics we use the differential equation and solve those differential equations. In statistics we solve the differential equation. In satellite launching and rocketry and missile firing, in all cases what do we do, how do we predict, and how one get to its target? In all cases the differential equations are solved, not necessary theoretically or in closed form, but they are solved numerically. And for the sake of for getting better and better approximation, and for it the approximation depends on us how accurate we need for our model. And also just if you have seen in case of chemical kinetics, the chemistry people also use the differential equations. And in case of meteorology, in case of astrophysics, in case of thermodynamics, that is in physics, in the whole physics, in any branch of physics the differential equations are used, and they not only give us information but changes our view, and also give some more insights about that model. Just like in case of we have seen the Newton's equation, and Newton's law of cooling, it is also a differential equation. And that you have seen what is wave equation, what it is also a differential equation which was given by D'Alembert in 1750. And in case of and that D'Alembert equation was used by great Maxwell, and he, he made and write down the all equations of electrostatics or electromagnetism in differential form, and solving those or manipulating those he get a wave equation. and formulated the theory of electromagnetism. That is, he also predicted about the new theory and also a new insight which was beyond our understanding, and one could not expect if we don't solve those equations or those differential equations. That is, light is also an electromagnetic wave. And in case of quantum mechanics, what do? We solve the Schrodinger equation, and by solving that equation, we tell about many systems and many complicated systems at microscopic level, at microscopic domain, that is inside the nucleus what is going on, and at the atomic level what is going on. So, and in case of, you have seen in statistical mechanics, what do? We solve the differential equations. So differential equations have the wide applications, and whenever we talk about a physical model, the differential equations are involved there. So uh, this video is going very long, so I would like to cut it here, and in next I will also I'll want to discuss about some history and more about these applications. So take care.